Everybody, thank you all for joining. I'm really excited today because we've got a couple of really great talks lined up for you. So I'm just going to do a quick intro and then we'll get going. So we're going to be talking. So last month, if you joined us, you remember we were talking all about our new Snowflake emulator. So this month, we're going to be talking a little bit about AWS. We're going to be talking about like doing CI/CD with our AWS emulator, and we're going to be talking about also some Snowflake. So we're going to be doing DBT workflows with Snowflake. So this should be really interesting, regardless of which emulator you're into. So this is what we've got lined up for you. We're already in the intro and welcome. This is where we are. So we've got two sessions lined up. One from Viren, who's going to be talking about emulating AWS CI/CD pipelines with LocalStack. We're going to do a little Q&A after that session. We've also got Harsh coming up he's going to be talking about running DBT workflows. This is with Snowflake using LocalStack. And then we will do a little Q&A and then say our goodbyes. So we are welcome to everybody. I'm really grateful to all of you. It looks like we've got quite a number of viewers today. So I'm grateful to everybody for joining us today. For those of you who are new, we do this once a month. So we always have some sessions and speakers. So we're excited that you joined us this month. So speaking of the speakers, I am Brian Rinaldi. I lead DevRel here at LocalStack. So on my team is Harsh. Harsh, do you want to introduce yourself?
Sure. So, hi everyone. Grateful to meet with you again. It has been a while since I have been part of these meetups, and it's always a constant to and fro when I see myself in the host and I see myself in the speaker. Sometimes I find myself in the audience or the backstage. But again, happy to be here and happy to be advocating for our new and great product, Snowflake Emulator. So, yeah, I guess I can pass off the baton to Viren.
Thank you, Harsh. I'm Viren Nadkarni. I'm a senior software engineer at LocalStack. And yeah, excited to be here and speak about all the cool stuff that we've been building since the beginning of this year.
And the interesting part is, like, for all the veteran audience that we have, Viren has been a constant speaker in our meetups. So welcome again, Viren, for another one of these.
Awesome. So, okay. Thank you all. Looking forward to your talks. So we've got multiple ways to participate here. We'd love for you to just add your comments in whether you're on LinkedIn or YouTube. Just go ahead and ask questions or add comments. We enjoy the kind of interaction during that. But also, if you have questions, you can use slido.com. That's where we'll collect all the questions for the Q&A. You can scan that QR code or use the code that's on the screen there to sign into Slido and then post your questions for each speaker. As I said, we will do the session and then we will get to Q&A at the end. So whatever questions get asked, whether they're in chat or on Slido, we will ask them at the end of each session. Awesome. All right. Speaking of the sessions, let's go ahead and just get started. So I'm going to welcome Viren back on stage, and we're going to turn it over to him to talk to us about emulating CI/CD pipelines.
Yes, thank you very much, Brian. Welcome to the first talk of today's event. I will be talking about emulating CI/CD pipelines in LocalStack. This is the most recently added feature or rather set of services. It's something that we've been working for the past couple of months, and it lets you emulate the CI/CD services in AWS. Like I said before, my name is Viren Nadkarni. I'm a senior software engineer at LocalStack, and I was part of the team which built these CI/CD services. Apart from that, on the side, I maintain a bunch of other services like DynamoDB, EC2, Kinesis Analytics, among others. If you're not familiar with CI/CD, it stands for continuous integration and continuous delivery. The core principle behind this philosophy is these two specific things. Continuous integration, which means that small changes are merged to the master branch on a very frequent basis, and continuous delivery, which involves releasing software in short cycles and at a very high frequency. In the past, we used to have systems like the waterfall model, which had a very linear structure. The requirements were decided first, and then happened the implementation, and then the delivery, and that was it. There was no provision for feedbacks. The CI/CD system, the CI/CD set of philosophies incorporates these things. And the core focus is automating this whole process. The first, one of the steps is building your software, which might involve compiling the software or building a package, and then testing it out, running all of the various test suites, unit tests, integration tests, end-to-end tests, and so on. And then ultimately releasing it, which could be either by publishing the package or the software, or deploying it by provisioning the infrastructure. AWS markets these set of tools in their developer tools category. Today, our focus is to focus on 5 of these services: CodeBuild, CodeDeploy, CodePipeline, CodeArtifact, and Code Connections. There's a bunch of other services in this same category, but they're out of the scope of today's talk. They're Code Commit, Code Guru. Some of these services have been deprecated, others have been renamed, but we're not going to talk about that today. Let's start with CodeBuild. CodeBuild is the build service on AWS. If you think of Docker build, when you're building an image using Docker, you specify a series of commands which are run in sequence, and ultimately you get an output, the artifact, which is the Docker image. CodeBuild works in a similar manner. There's this file called the build spec, where one specifies the list of commands which need to be executed in order for the build to finish running. And all of this happens in an isolated environment. It's basically a container. You can configure the environment in which these commands run, like the pre-installed software, if you have any need for libraries or compilers and so on. You can choose the operating system. By default, it's Linux, but you can also select Windows or Mac if your software requires it. And of course, you can also customize the resources that are available to you, the compute resources like the CPU, the memory, whether you need a GPU or not. And most of the time, a CodeBuild project produces output artifacts. That's why you need the CodeBuild project for. There's a bunch of other functionality that CodeBuild also provides, like caching to speed up your execution, you can specify the retries. If a certain command fails, you can choose to retry the whole project, reporting, and so on. Now, CodeDeploy is the deployment service. It has a very tight integration with other AWS services which run web services like EC2 or ECS or Lambda. And this tight integration lets it provide features like the ability to use various deployment strategies. You could perhaps choose to select blue-green deployments, which helps you. The core goal is to help you with fallbacks and reverts. If you realize after deploying that the software is faulty, you can instantly roll back to the previous version. CodeDeploy uses a specification called AppSpec, and the specifics of AppSpec varies depending on what the target service is. EC2, for example, has something called lifecycle hooks, where you can set what happens when certain events happen in the lifecycle. In similar manner, Lambda has validation tests, which let it identify that the Lambda function itself is running, and so on. Now, CodePipeline is the core service of this whole CI/CD ecosystem on AWS. It handles the pipeline orchestration, and pipeline themselves they are the core construct in the CI/CD principles. It's specified as an acyclic directional graph, and the steps in the continuous execution, integration, and testing are specified, are built into the design of the pipeline. Like you saw with CodeDeploy, CodePipeline has a very tight integration with other AWS services, S3, ECR, CodeBuild, and so on. We also have Code Artifact. Code Artifact is a service that lets you create package repositories. You could choose to have private repositories or public repositories, and it works very similar in a similar manner to JFrog Artifactory, if you're familiar with that. You can create registries for various types of programming languages. Say if you have a PyPy package that you need to publish, you could create a repository on Code Artifact and publish it there without resorting to use the public PyPy registry. On AWS, there's support for a variety of these package repository types. Now, where does LocalStack stand in this ecosystem? In LocalStack v.5, which went out the beginning of this month, we've added emulation support for CodeBuild and CodePipeline, and we've added mock support for CodeDeploy and Code Connections. And up next, we are expecting to get Code Artifact out. We've been working on adding mock support, as well as initial support for emulating NPM registries. So yeah, we're expecting to get it out, in this upcoming release of LocalStack. Right. So let's jump into the details. So the plan now is to understand build specs and pipeline declarations in a greater detail. We'll create a CodePipeline pipeline, which will fetch some source code from GitHub. It will compile the project and produce the binary, and then upload the binary to S3. And to make sure that the binary was compiled correctly, we'll download it to our system, and we'll try it out. All the source code that you'll be seeing now is available at this link over here. You can try it out later if you want. So for the specific project that we'll be working with, we'll be using this very nifty tool called FZF. It's a fuzzy finder, and I use it on a daily basis. I use it for its Vim integration. It's a Go project, and you can check it out at the link here. Now, let's take a look at what build specs look like. As I said before, build specs are YAML files. They are structured. It has a structure of consisting of various blocks, and each block serves a different purpose. Over here, the block that you see highlighted is the install blocks. In this block, you specify the runtime version that you want. Runtime version is basically the base image, the environment in which the commands run. Because we are dealing with a Go project, I've chosen Golang runtime environment with the 1.22 version of Golang. If your project uses a different programming language, you could choose a different one. Like there's support for .NET, Java, Ruby, Python, and you could also choose a different OS if that's your requirement. The next block, the next series of blocks determine the life cycle of the build process. There are three stages in a build. The first is the pre-build stage. In this stage, you set up the environment. Like if you have a need for additional libraries or additional compilers or additional software, which is not provided by the runtime environment, you can do it here. For our case, I've just specified go-get. Go-get will fetch all of the dependent libraries of the project that we're trying to compile. The next stage is build, which is the central stage. This is where the core compute logic happens. And here we have go build, which will compile the Go project for us. There's a third stage, post build, which is omitted in this example because we don't have a need for it. That stage is used for things like cleanups and just clearing up the environment. This block here, the artifact blocks, defines the output of the CodeBuild project. It informs CodeBuild that only a few set of files are important, and everything else has to be discarded. Like I said before, CodeBuild has a bunch of other features, retries, reporting. None of that is used in this example because we want to keep this as simple as possible. Just make it easy to understand. Now, what we saw explains how the project is built. But there's a bunch of other things that we need to do before we can even build the project. We still need to retrieve the source code. And after the project is built, we need to do something with the output, the FZF binary that was produced. That's where the pipeline comes into picture. By using a pipeline, you can organize the flow as as a well-organized system. Here you can see this sample pipeline that we're going to be working with. And the pipeline is divided into stages. Each stage, so here we have 3 stages: source, compile, and publish. And within each stage, there are actions. CodeBuild, what I just explained, is an action, and that falls within the compile stage. You can have multiple actions in each stage. And when you have that, all stages execute in parallel. But again, CodePipeline is very flexible. You can also choose to execute certain actions before other actions in a given stage. Now, this pipeline that you see here will do, it will retrieve the source code from GitHub. I'll explain in detail how all that works. It passes that source code to CodeBuild. CodeBuild will use the build spec that we just saw to compile the project. And then the pipeline will upload the binary that was produced to S3. Now, the pipeline that we saw is described using the pipeline declaration. There are metadata fields at the very top, you have the metadata fields for version. This is a V1 type pipeline. There's the pipeline name. There's a role on field. Now, this is of particular importance. In AWS, everything, if a service can't access other resources unless explicitly permitted, and that's done using IAM, and the role has to have the proper permissions, and that role has to be assigned to the pipeline so that the pipeline can access these resources. Next, we have artifact store field. CodePipeline uses an S3 bucket as an intermediate storage. So the output of the first stage, the one to the left, code connection, is placed in an S3 bucket. That's the artifact bucket before the CodeBuild stage can pick it up. That's where this section comes into picture. And all of this is followed by the stages, the stages that we're dealing with. We have 3 stages: source, compile, and publish. The first stage, source, just has one action. And in our case, we are using this service called Code Connection. Code Connection is this meta service in AWS. It deals with integration with other GitHub repositories. It also identifies triggers. So triggers are when the pipeline needs to be executed. You generally want the pipeline to be executed when a commit is made. But yeah, that's all of the other stuff. The important bits here in this piece of code is the repository ID that you can see at the bottom and the branch name. Pay attention to this branch name. So we are using version 0.62. This will be important later. The next stage is compile, where again, we just have one action. This is essentially the same thing that we saw earlier. It just runs the CodeBuild project and produces the binary. One important thing to notice is the input artifacts and output artifacts field. CodePipeline makes use of these values to determine how the artifacts of artifact flow between multiple stages. Here, the input artifact is source code, which happens to be the output artifact of the previous stage. And then we have the third stage, which is publish. In this stage, we just take the binary that was compiled by the previous stage and upload it to S3. Now, because we want this example to be very simple, we just publish it to S3. But you could perhaps use CodeDeploy to deploy your binary to wherever, if you're running on EC2, or you could use code artifact to publish the binary to a registry. Now, if you put all of the pieces together, this is how the pipeline actually looks. The code connections action retrieves the source code from GitHub. It puts it in the artifact bucket. Then the code build action retrieves the source code from the artifact bucket, does its thing, and then puts the output, which is the compiled binary, back to the artifact bucket. And then finally, the third action, S3 deploy, picks the compiled binary from the artifact bucket and uploads it to the output bucket. Okay, so let's jump into the demo. I have the LocalStack container running here in the background. And I'll be using AWS Local. AWS Local is a wrapper that we provide for AWS CLI. It just makes it easy for you to just use AWS, the entire AWS CLI with LocalStack. Now, the first step is to create the prerequisite resources. CodePipeline, pipelines do not create resources. When I say resources, I mean things like S3 buckets, or even code build projects. All of this must exist beforehand. So let's start with code connections. I said earlier that code connections handles the connection with the GitHub repo, and that at the moment the service is mocked. So we just need to create this code connection. Next, let's create the IAM policies. IAM has roles. So we have this role here, which just grants CodePipeline the permission to assume role. And we have this policy here, which just gives it blanket access to S3, because the pipeline needs to publish to S3, the compiled binary, which is. We can create the role using IAM create role operation and pointing it to the role.json file that you just saw. And then associate the policy with the IAM role that we just created. Now, moving on to code build project, here's the build spec. It's the same build spec that you just saw in the slides. We have the Golang runtime. We have two stages here to get the dependencies and build the binary, and we specify the artifacts. The pipeline, the project can be created using CodeBuild create project operation. The project that we just created can be seen using this operation here, these projects. So most of the resources, prerequisite resources, apart from the buckets, are remaining now. So a quick reminder, we need to create two buckets. One is the artifact bucket, which is used as the intermediate storage, which we can create using this command here. And we also need to create the output bucket, which will hold the compiled binary, the action taken by the last stage. Oh, output bucket. Right, so next, let's create the pipeline. Here's the pipeline JSON. Now, this is the JSON representation of the YAML thing that we saw earlier. CodePipeline works with both YAML and JSON. It's essentially the same thing. It's just displayed differently. We have the exact same structure here. There's the metadata fields at the top. We have 3 stages, and in each stage we have the appropriate action. And we proceed to creating the pipeline using the create pipeline operation here. Right? So the pipeline has been created. And you will notice that all of this happens super fast. That's because LocalStack is running right here on my computer. AWS CLI does not need to contact AWS servers to create these resources. The pipeline that we just created can be seen in list pipelines operation here. And when I created the pipeline, LocalStack also started executing it. The executions of a pipeline can be seen using list pipeline executions. And you can see here that the pipeline, it produces a bunch of useful information. It obviously says the status, which is successful, which is good. And you can see other stuff like the trigger. It was a create pipeline which executed this pipeline. Okay, so the pipeline has been successful. We can now take a look at the output of the pipeline, which was the FZF binary. It should have compiled, it should have retrieved the source code from GitHub, should have compiled it, and it should have uploaded the binary to S3. We can get the binary using this command here, so just S3 copy. If I try to take a peek at what this file is using file, it tells me that it's an executable, which is good. And in order to try to run this binary, I need to first give it execute permissions. And if I run the version command, it's 0.62, which means that this is the one that we specified in the pipeline declaration. So that's great stuff. I can just now, we have the binary ready, and I could just use it as I would, yeah. So yes, that was a quick demo of how Codex services run in LocalStack. This was a very simple pipeline. And on a production system, we probably wouldn't have a pipeline as simple as this. LocalStack support for CodePipeline is pretty good. You can make this pipeline as sophisticated as you want. Say if you want to have another stage between source and compile stage where you want to run tests, you can do that. You could perhaps also want to, rather than uploading it to S3, you could publish it to CodeArtifact or deploy it to ECS. All of that is supported. Right, so that was it. LocalStack now has support for CI/CD services, allowing you to design and test pipelines locally. You get all of the benefits that you get of having local emulation, the speed, the cost, and cost in particular is big here because AWS charges pipelines on a per pipeline basis, and each integrated service is charged separately. If you use CodeBuild, that is charged on a per minute basis on top of the cost of the pipeline. All of this adds up when you have a lot of pipelines. You'll obviously have a set of production pipelines and a set of developer pipelines, and that easily, the cost easily adds up. LocalStack brings a relief in this area, giving you a cost relief at the same time, providing a cloud-like experience. That was all. Thank you very much, everyone, for listening. I know this was a very information-dense talk, but I hope you find this useful. All of these services are now available on LocalStack, so please try them out. If you need more features, say support for a new code pipeline action, please reach out to us by raising a feature request on GitHub. Yes, thank you very much. I'm open for questions now.
Thanks, Viren. That was great. Yeah, so I think it's interesting that you talked a little bit about some of the benefits being around pricing, because I know, like in certain cases, using LocalStack a lot, like the biggest benefit is that you save a lot of time and developer experience. Like it's less so much the cost. But it sounds like in this case, it's a little bit of both. It's going to be much faster, but because of the way these services are charged, you're potentially saving a lot of money. Am I understanding correctly?
Yes, and especially adds up when you have a lot of developers. You're gonna have different pipelines. Each developer will be working on their own set of pipelines.
Yeah, for sure. And I saw that Ravi was asking a question whether this was running on LocalStack or AWS. But was all what you were showing was running on LocalStack. So, and the idea being it would be actually the same. You could then deploy this pipeline to AWS and it would function identically.
Yes, that's correct. You can, suppose you're traveling in a train where the internet connectivity is spotty. You could easily spawn up a LocalStack instance and continue your work. And at the end of the day, when you have proper internet, you can deploy it to AWS.
Nice. And so I know you mentioned that the NPM support is coming, and you said it's fully emulated. Can you tell us more about that?
Yes, Code Artifact has Code Artifact on AWS has support for a bunch of registry types. We are starting with NPM emulation, so you can create NPM repositories locally. We also adding upstream support. So upstream support is kind of like a proxy. If you're trying to install an NPM package, so first you need to configure your NPM system locally to point it to LocalStack. And you can download the packages that you've published to LocalStack. But if you're trying to download a package that doesn't exist in LocalStack, there is support for upstreams. So LocalStack will transparently get the requested package from the official NPM registry and let you install it.
Awesome. So just for the viewers, we anticipate we're going to be releasing that new version. That's coming in the next release. That's the one coming this week.
Indeed, yes, that's the plan.
Yeah, all right, exciting stuff. I just wanted to confirm. So yeah, you can, if you're interested in that, look for our release updates, hopefully later this week. So Mark was asking, what console tool did you recommend at the start? And that was I think it was the FZF. What tool? Tell us what exactly does that tool do?
Yes, well, it's just a command line productivity tool. It lets you search a bunch of stuff on a very quick response basis. You can search the file system for files, or if you have, it has integrations with Vim. So if you have multiple files open in Vim, you can use FZF to switch between files. So, it's just an example project that I just picked randomly for this demo.
Nice. And Jesus was asking which version was used for the example. I think he means which LocalStack version, which we said this was in 4.5 and up. If I'm understanding the question correctly.
Yes.
And which plans is it available on?
Yes. So right now, all the CodeX services are available on the highest plan on LocalStack. But I should be able to sign up a trial to give them a go.
Right. So that would be so not on the basic, it would be Ultra Okay. Okay. Awesome. And okay, we got one more question. What is being used for CodeBuild? I'm using CodeBuild agent for local testing.
Yes, that's exactly what we are also using. For some background information, AWS provides CodeBuild agent, which is a tool that it's an official AWS tool, which very closely emulates how CodeBuild works on the production AWS. We also use the CodeBuild agent with the tight integration with the API, adding the API layer on top of it.
Right. But the benefit, of course, of LocalStack is you get the full end-to-end everything, right? So
That's correct.
as opposed to like, yeah, okay. Awesome. Okay, well, really appreciate your talk, Viren. This was great. Oh wait, we got one more question I want to get to real quick, which is does it have a console log during build?
We haven't added that yet, but it's on our roadmap.
Okay.
Right now, you'll need to use the workaround of checking the logs in the Docker container itself. So use the Docker logs command and check the logs of the build. We plan to have integration with CloudWatch logs in the future to just make this whole experience very seamless.
Excellent. All right. Well, again, thanks, Viren. I really appreciate the talk. Really appreciate the answers to all of our questions that came in. And we, appreciate you coming out. So we'll move on to our next talk. All right. Yeah, here we go. We welcome Harsh back to the stage. So Harsh is going to change gears completely here, right? And sort of. We are now leaving AWS world and moving into Snowflake. So Harsh, tell us more about dbt workflows in Snowflake.
Sounds good. And this is a pretty fun talk because I technically learned about dbt just a couple of months back, and I had to demo it to over 100 plus folks when I was at the Snowflake Summit just this month. So it was a fun experience, and I guess I will be showcasing the very same demo. So let's get back into it. Hi, everyone. My name is Harsh, and as Brian already introduced, I will be talking about how you can run dbt workflows locally using LocalStack's Snowflake emulator. So my agenda is pretty straightforward. We'll understand what dbt is for anyone who has not came across this before. And we'll try to dive into some challenges that teams particularly face if they're trying to build dbt workflows, especially against production Snowflake instances. So things like latency, cost, the overall developer experience, and all of these things. After that, I will introduce you to the LocalStack for Snowflake emulator and actually show you how you can use to develop and test these dbt workflows right on your laptop. And I will be covering up like how you can set up a local dbt environment. You can connect to the Snowflake emulator, run your models without touching a real Snowflake account unless and until you're ready to deploy. All of this with a hands-on demo to just show you how all of this basically works in practice. So without much ado, let's jump directly into the talk. So yeah, let's maybe talk a bit about what dbt is and just give a background for this overall session for anyone who is not familiar with this. So dbt stands for Data Build Tool, and what you can imagine this as, like, it's an open source tool that simplifies your whole data transformation process within a data warehouse platform, something like Snowflake. The key thing to understand is that dbt specifically focuses on the T in the ELT, so basically the transformation part. So what it does is, like, it takes the raw data, it transforms that into something of a structured model that you can query, and something that your business users can basically start working with. But one thing that we should keep in mind is that dbt isn't just for transformations. You can actually like bring a lot of best practices that you find in the software engineering world. So stuff like modularity, version control, testing, automated testing, and comprehensive documentation. And as you can see in this diagram from dbt labs, you can basically fit dbt between your raw data and your transformed data. And once the data is transformed, once it is ready, you can actually start feeding this into whatever BI tools that you're using right now. Going next, yeah, one thing that we can basically talk about is that the challenges that developers most commonly faced while they're trying to develop and test like their dbt models. So dbt is great, but obviously developing it against production Snowflake instances would also come with some real challenges, something that we have already seen in the AWS ecosystem. The first thing that I would like to say is that there is something that I call as the testing tax. Every time you run dbt during development, you're always going to consume very expensive Snowflake compute credits. Now, if you're doing this once or twice, you won't be able to notice that. But slowly over the time, if you have got multiple developers working on the same project, this adds up very quickly, especially when you're iterating on any complex transformations. Second, developers often don't get any real-time feedback on the cost. So you might write code that seems very convenient for you, but that actually ends up being very expensive to run. And you only find that out when the bill actually arrives. And the third, there is obviously going to be a latency issue. So if you're querying any significantly large data set, you might end up just waiting minutes or even hours for getting your results. That's time. That's a time that you could actually spend on much higher value activities. There are many other issues as well that I have not listed over here, but you can just imagine stuff like data loss, data corruption. That is very common during development and testing phase. The data governance is going to be a very hard thing to tackle because if everyone has got access to production data, that's going to create so many compliance issues during your development phase altogether. So considering these challenges, you might start wondering what exactly is the answer for that. And I guess like this is something that a lot of other data developers have also noticed out in the community is that what if you could just run dbt locally? Because right now, dbt development typically requires a very good connection to a remote Snowflake instance. And this does not fit well into a local first development lifecycle that most of the software engineers might already have experience with. Uh, so the question really is there any way to run a local data warehouse just for development and testing? And I guess we went through a lot of these community posts on Reddit, on Stack Overflow, on different platforms altogether. And we noticed that this isn't a new problem. It isn't something that we are trying to solve for. It is something that most people are facing nowadays. Many developers are just looking for a way to build and test their dbt models locally to achieve two simple goals. They want to save the money and they want to increase their development speed. So the ideal development experience is very simple. And this is something that we basically had a mind map about, and we basically went on to tackle this. You want to set up your dbt project, you create a local dbt profile, you start a local instance that emulates some sort of a warehouse operations, you run all your dbt commands to validate your changes, and only then push your finished code to production via a CI/CD pipeline. So this is where we introduce LocalStack for Snowflake. If you attended our last meetup, we basically released the LocalStack for Snowflake 1.0 product last month, and we did the GA this month, which basically means that now you can use our product to basically emulate Snowflake directly on your local machine without having to really connect to any real Snowflake instance out there. So this product is shipped as a Docker image. You can typically install it on your laptop or your CI environment. And the key thing is that it is actually emulating the real Snowflake API surface. So you can integrate natively with all the existing Snowflake tooling, and that basically includes dbt as well. So once you have this emulator running on your machine, your JDBC connections work, your data visualization tools work, and everything works out of the box because we are providing the same API that the real Snowflake does. And because it's containerized, it's really easy to extend this particular development model from your local machine to your CI pipeline for all the automated testing and development purposes. So you might be wondering like how complex it would be to set up dbt with LocalStack for Snowflake. And turns out that it's pretty straightforward. All that you need to do is just create or modify your profiles.yaml file that you might have initiated for your dbt project and include all the connection details for the LocalStack emulator. So the key thing that you will need is setting up the LocalStack host, which in this case is going to be snowflake.localhost.localstack.cloud. This is entirely running on your machine because we ship a DNS server alongside our Docker image. And apart from this, you just like need to set some test credentials. So stuff for your username, your password, and optionally, you can also like fill in your database parameters, your warehouse, and all of these particular things. You can just set all of these things to test, and it would just work out beautifully. The best part about this is like it's very much like a regular Snowflake profile. So your existing DBT project does not need any particular changes over here. And as I mentioned, you can basically use the same set of commands that you use for running your DBT models. So you can just do a DBT run and you can configure the profile to the one that you created for your LocalStack emulator. And this will just work out in the same way. The reason for that is because we strive for a one-on-one parity with the real Snowflake API. So you don't need to make any changes to your models or any of your existing code after all. Like your DBT project just works locally, which is pretty great, in fact. Now, with all of this done and having a very basic idea about what LocalStack for Snowflake offers and how you can get started with DBT development locally, we can talk a bit about the demo that we will be looking at. So in this demo, we are basically going to build an end-to-end data pipeline for a smart factory monitoring application. And we will be running the entire thing locally. So the general pitch is like, just imagine you have got a smart factory, you have got a bunch of different machines, and each machine is tracked by different IoT sensors, and it's collecting all sorts of data. You're basically getting stuff like machine IDs, timestamps, temperature, vibration, pressure, status code, and all of these things. So you have got all of this data in CSVs, and they are being stored on the S3 buckets. And you want to have a pipeline that basically ingests all of this data from my S3 bucket, passes it through Snowpipe, and then you can apply your DBT transformations, and everything can be queried via a locally running Streamlit web app. Now, these DBT transformations can be either done manually, like you can individually execute DBT run, or you can actually run an orchestrator like Dagger, whatever basically fits your workflow. The key thing is that everything runs locally, so you can develop and test this entire data pipeline without actually touching any real cloud resources. So let's jump straight into it and see what this demo has got. So I have got everything running on this GitHub code space. And as I particularly mentioned, we have got the CSV file, which is sensor data batch1.csv. And as you can notice, we have got machine IDs, we have got timestamp, temperature, vibration, pressure, and status code. So the first step in this process is going to be starting our LocalStack for Snowflake emulator. The way that you can do that is using the LocalStack CLI. And in this case, I'm just going to specify LocalStack start. And I'm going to specify the stack flag and mention that I want to start the Snowflake emulator, in fact. If you're coming from the AWS emulator, like this command might look very familiar, but under the hood, it is just starting our official Docker image as a container. So you can technically use Docker CLI or Docker Compose or any container orchestration tool to get started with this. I'm using the one that is the simplest that I can use. So as soon as you execute this, this is going to start up my emulator. And as I mentioned before, it is going to expose the emulator on snowflake.localhost.localstack.cloud. And this is what we are going to use to integrate my DBT workflows or whatever integrations that I'm looking to use to get started with the whole thing. So if we just go back to our architecture diagram and let's looking just at what we want to achieve with this process, is that the first thing that we want to set up is all my actual Snowflake resources. So this would mean my schemas, my databases, my tables, my Snowpipe, and all of these things. So basically have my Snowflake infrastructure already running so that I can start integrating the other pieces to this. So let's go back to my code space and let's actually go ahead and create all my resources over here. So I'm using a makefile target for my particular purpose, but under the hood, it is using a very simple command, which in this case is executing the setup Snowflake SQL script. And if I actually show you the script over here, this is creating my database, my schemas, my tables. I'm setting up a file format for my CSV file. I'm setting up a stage that points to a local S3 bucket. So this is where my CSV file is going to get uploaded. And this will trigger the Snowpipe, which is going to automatically ingest all of this data right in. So let's go ahead and let's execute this. And this is going to use the official Snowflake CLI that has a connection set to my LocalStack emulator. And this is going to create my database, my schemas, my tables, and all of these things. And once this is done, you can actually notice that my database is now seeded successfully, which means that everything has now been set up. The second step in this process is going to be creating my S3 bucket, which is going to be instrumental because we have got a stage that's pointing to my local S3 right over here. So I can go ahead and I can just say make AWS. And this is a very simple Python script that uses Boto3 to create my local AWS resources over here, which is the S3 bucket in this case. And finally, I can go ahead and say make upload, which is going to upload this sensor data batch1 file to the local S3 bucket that I just created right now. So go ahead, do a make upload, and you can actually see that my file has been uploaded, which means that we can already start running some preliminary queries because we have got some raw data already available in my Snowflake emulator. So I can switch back and I can show you some of these SQL queries that we can run. In this case, I'm using the Snowflake's VS Code extension. So I can just go ahead, click on execute, and you can actually see that it's using the same Snowflake SQL dialect. And I have pointed this to my LocalStack emulator, like right in this case. And this is like already like doing the job of like running everything against my local emulator and getting me all the data that I particularly need. So you can see that I have uploaded 500 records in my LocalStack S3 bucket right now, which is now also available in my Snowflake database. I can also execute this, and you can get to see the top 10 data available right in this case, which is very instrumental for all sort of development and testing processes. So now that we have this done, we can actually go ahead and like do the next step in this process, which is going to be the dbt transformations. So in this case, what I can do is I can just run make dbt. And this command is technically wrapping up like this very simple command, which is dbt run, setting up the profile to LocalStack. If I actually show you my profiles.yaml file, you can see that in this case, I have set up a LocalStack profile over here. The type has been configured to Snowflake. And for rest of the data, I have pretty much set test credentials. The database has been set to factory pipeline demo, which is the database that I'm using for my demo app. And the most interesting part is that the host is set to snowflake.localhost.localstat.cloud with the port being 4566. So that's all you need. You can just technically drop this in right in your dbt project, and you can like technically run your dbt workflows locally without having to do anything else. So I can just go ahead, do the make dbt command, and this is going to start executing my dbt models. And the very best part about this is like it's pretty instantaneous, it's pretty fast. So you don't have to like do any of the other things to like hyper optimize your development and testing phase. And as you can see, like we had just like an incremental model, a view model, and a table model. It is now completed successfully, which means that our data has now been transformed and it is finally ready to be queried by any particular BI tool. In this case, I'm just using a simple Streamlit app for demo purposes. So I can just like do make Streamlit, and this is going to activate my Streamlit app, which is on this UI.py file. And I can show this to you on the other tab that I have right over here. And hopefully the demo gods are with me, and this should not hopefully break. Yes, it is not breaking. So you can actually see the smart factory health monitor running right over here. We can see that we have got 10 machines. One of them is healthy, 2 of them is critical. And that's the average risk score that we have got. And all of this is basically getting the data right from whatever data is basically transformed by the dbt project that we have got. So yeah, that's how easy it is for you to get started with like running your dbt workflows locally. The best part about this is like you can technically integrate dbt with any data orchestration tool that you're using right now. So you can use things like Apache Airflow. LocalStack has already got support for the managed Airflow service provided by AWS. You can also use things like Dagster or Prefect, for example. In this case, I have got a simple setup that can show you how you can run a Dagster pipeline in conjunction with your dbt project. So if I just do a make pipeline, and this is going to activate my Dagster project and my Dagster services, you can actually see that this is running on localhost 3000. And if I switch it back over here, that's where I can see all of my dbt models. I can see the runs, and I can see the other aspects of this. For example, I have got an S3 file sensor that's automatically gonna execute my dbt models once it finds a new file in my S3 bucket. So if I actually show you how I can test that is I can go right here, And I can just say that I want to upload another file, but in this case, I want to upload the latest batch file that I have got. And this is gonna upload my file again to my S3 bucket. And if I go back right here and show you this, it's gonna take a few seconds, but you might start noticing that a new run has been invoked. And my Dagster pipeline is gonna take up all the files. It is gonna re-execute the dbt workflow. And once it is done, it is gonna put the whole data back into my final table, and you can query that directly from your Streamlit app. So let's hope that this is actually invoked. Yes, it is. And you can see all of the data logs right over here. And this is going to take a few seconds because it's going to execute both the dbt models that we have got. And it is also going to execute all of the tests that we have in this case. So I guess that's the best part, because not only you can build your data dbt models and validate them locally using the LocalStack emulator, but you can also start running your tests directly against the Snowflake emulator, and you can get to see if you're basically passing through all of the data quality testing or all of the other testing that you have particularly got for your project. So we can leave it running. It's going to be successful. Hopefully the demo gods are in this case. But yeah, we can basically switch back to this, and we can have a fully local data development and testing workflow running directly on your machine. In this case, it's a code space, but yeah, it does not matter. You can basically take the same container and you can technically run this anywhere you want. So switching back to the slides, I guess we are very much at the end of this particular talk. But a few of the points that I would like to emphasize for this is that LocalStack is here to basically enable a shift-left approach for dbt developers. So you can technically use this particular development model for rapid prototyping, for safe experimentation, and you can get incredibly fast feedback since everything is running locally. The best part about this is it eliminates all the testing tags, and you can just debug your entire workflow and not just a single model. So this local development model, so you can use that for all the rigorous testing, and you can run your whole stuff on your local machine before you actually push your code to production. And this is obviously going to lead to a very high quality data development process. Now, if you're a part of a team and you might be wondering how should I exactly get that data in my Snowflake emulator? So right now you have got two ways. You can either manually load your data using a stage or using a storage integration or something similar. Or you can use some of our technologies like CloudPods that basically allows you to take a state snapshot of your LocalStack instance, and you can distribute that across your entire team so that it can foster a very efficient and collaborative environment for all sort of data development. Maybe one of the future meetup talks is exactly going to talk about this whole development process. So this brings us to the end of our presentation. So thanks everyone for staying till the end. And I would love to take up any questions that you might have about running dbt locally. And you can obviously find me on social media or on LinkedIn if you want to continue the conversation. And please join our community on LocalStack. We would love to have you there to discuss about LocalStack, about our Snowflake emulator, or about local development workflows. And it's going to be a great place for all of these great conversations. So thanks again. And yeah, I can take up any questions up there on the chat.
Great job, Harsh. That was great. I obviously I've seen that demo, but I think it's a really good representation of how to get the full end-to-end, not just the Snowflake part, but then dbt part as well as the Dagster part. So all the pieces are in there. One thing you mentioned, which I just want to kind of clarify for folks, you talked about using an S3 bucket, and obviously we're talking about the Snowflake emulator, and S3 is not a Snowflake service. So can you explain more about how S3 plays into this whole thing within our Snowflake emulator?
Definitely. So I guess one of the things that we have noticed often in the Snowflake ecosystem is that a lot of the customers and the users particularly have got their data sets directly on an S3 bucket, and they particularly create a stage or a storage integration that points to the S3 bucket, and this is where you can fetch the data from, and this is where you can start running your dbt workflows. So that's one way of doing things. The other way is obviously going to be directly uploading your data to your Snowflake instance. But the best part is like LocalStack already supports and provides a very good support for various AWS services, including S3. So if you have a similar kind of a workflow, you can definitely use that. And with some of the new developments coming up in the future, you might see support for more object storage solutions for other clouds as well, particularly Azure, like is something that I'm pointing at. But yeah, this is where you can technically use S3. But let us say that if you have a big data set on S3, and let us say that you cannot load everything into your local instance. So we have got specific config variables that allows you to trim and query only a subset of data from your remote S3 bucket. So these sort of hybrid development models are also available in our product right now. So if you have something similar, I would implore you to reach out to us, talk to us about all of these things that you have got in mind, and we can definitely suggest you a solution about how you can make an efficient data development workflow for your team.
Right. But just to clarify that S3 bucket was running on your local machine. It's just
Exactly.
we
Yeah.
include emulation for S3 in the Snowflake emulator.
Yes.
Right. And then the other thing was, can you? I know you didn't really cover it, but can you do like a native app with Streamlit? Like,
Yep.
I know. Yeah. Go ahead. Tell me.
Definitely. So I guess the easiest way is like within this project itself, we have got a native app set up already. So for people like who don't know about native app, like this is one of the ways that Snowflake provides you to deploy your Streamlit apps directly on the Snowflake data cloud. But more importantly, I guess native app is something that people use for deploying their Snowflake apps directly on the Snowflake marketplace. I guess that's the big use case right over there. But like in our experience, we have seen a lot of customers trying to use like native apps and trying to deploy their native apps from the CI/CD to test everything out. So with this project, you can basically go and do something as simple as a make app. And this is going to use the Snowflake CLI. This is going to run my native app by directly connecting with my LocalStack emulator. And it's going to create my application package, my stage, and a few more resources. But once done, you can pretty much use the very same way in which you see the native app running on your Snowflake data cloud. But in this case, it's going to be running on your local machine. So yes, that's very well supported. And that's something that we would very well suggest you to try and check out.
Awesome. And just for folks who are listening, if you do want to try out the Snowflake emulator, we have a 30-day trial available where you can test it out for free. I think the key thing when we went to Snowflake, because you and I were there together at the Snowflake Summit, I honestly I'm not like that familiar with Snowflake, so it was new to me, but apparently Snowflake credits are not cheap. That's the sense I got from everybody I spoke to. So this would allow you to do all of this without having to like consume credits. I think the bigger issue for people we've talked to was also not just like individuals obviously consuming credits, but if you had teams spread across different time zones, they were spinning up the what do they call it? Not workspace. What they were spinning up the environment in the cloud. I can't remember the terminology for in Snowflake that consumed credits and would stay running, but because they were spread across time zones, it's spinning up and running the whole time, consuming credits practically 24 hours a day. So you can give your teams access to Snowflake. They can test this stuff, they can do all their work without necessarily needing to consume any credits. And you can kind of automate all the testing and everything like that with using LocalStack. So hopefully if you're using Snowflake, give it a try. Again, it is a new product from us, so we definitely would love to hear your feedback on what features are missing, what things you would like to see to improve your workflow. So yeah, we're always looking for that kind of feedback. And for both of our products, to be quite honest, so AWS and Snowflake, but especially because Snowflake is new. And on that note, I know we talked a little bit about the Slack, but as part of our goodbye, I want to just kind of can we bring back up the Slack URL? Because this is a great way, like if you're not after this event is over. We only do this once a month, so after this is over, if you want to kind of chat with us, our Slack community is there for you. We're there to answer any questions you might have, but also you can meet other folks who are using LocalStack. So we'd love for you to join us there after this meetup. So with that, I'm gonna go ahead. Thanks, Harsh. That was fantastic. Yeah, Jesus says thanks as well. And I'm gonna go ahead and just kind of do our goodbyes since we're already at time. But thank you all who stuck around and watched. I hope we taught you something today. And again, I hope to hear from you either on our Slack or on social media. Please reach out to us. And we will be back again next month. Follow the meetup page for any, or on YouTube for any updates on when the next meetup will be. We'll see you next month.